Here we have our 12th sample question. So you're getting kind of close to having a test. We only have 2 more sections that we have to cover, 5.6 and 5.7. So just be aware. For this guy, again, notice it says simplify, and we have 3 trinomials. So how do we get rid of the parentheses? We do not do power rule because we just said that they're trinomials. We have to distribute the outside coefficient. Now notice each of these parentheses don't have one. So anytime you don't see one, you slip in a 1. If this had to happen a 5, then you just distribute a 5 out. But for these guys, they don't have one, so slip in a 1. And when you distribute here, since this does not have a sign, it's understood as positive 1. So you're going to get 2p cubed minus 5p squared and a positive 7. So nothing changed because we're distributing by a positive 1. Notice we're going to distribute this guy by a negative 1. Remember, distribute by the number and its sign. So negative 4p cubed. This will become negative 7p squared. This becomes negative 1p. Notice all I'm doing is just doing negative 1 times positive, change the sign. Negative 1 times positive, change the sign. Negative 1 times positive, see how it became negative instead of positive. And then the last guy, distribute its number and sign. So we're going to have negative 1p cubed. We're going to have positive, negative times negative would be positive 5p. And then negative 1 times 11 would be a negative 11. Okay? So positive became negative. Negative became positive. Positive became negative. Once you have this written out, then you can collect any like terms. So remember, when you're doing this, it might be helpful to start with the alphabet. So notice we only have P's. Remember, if you had P's and A's, then we would do A's first. Start with the highest degree and work your way down. But here we only have p's, so the highest degree or exponent looks like p cubed. That's the highest one. We have 2's, we have 3's, so 3 is the highest one. So let's see. This can pair off with this, which can pair off with this. See how they're all p cubed, p cubed, p cubed? Even though you have 3 items, just do 2 at a time. So just do 2p cubed minus 4p cubed. You know, a positive and a negative, we're going to get negative 2p cubed. Then bring over the other guy. Now this is a negative and a negative. So 2 negatives add. We're going to get negative 3p cubed. So it depends on how you do this. Some people are mental math and say, okay, 2 and a negative 4, it gives us a negative 2. Negative 2 and a negative 1 would be a negative 3. And then you know p cubed is p cubed. Or just do 2, the first 2 at a time, get an answer, and tack on the last one. However way you work them. Now let's do the next p squared. So this and this. There's no other p squares. So this is a negative. This is a negative. So you know 2 negatives, we're going to add. So we're going to get 12. Remember, p squared has to stay the same label. But who wins the tug of war? 7 players or 5? Team 7. So it's going to be a negative. Now the single p's. We got some here and some here. This is a negative. This is a positive. So again, different signs, subtract. Sometimes we'll be adding, sometimes we'll be subtracting. It's all about those labels, tug of war. So different, we're going to get 4. Keep the same variable part, p, p, p. And then who wins the tug of war? 1 player or 5? Team 5 wins, so team positive. And now do your constant term. We got constants here, and we have a constant here. So this is a positive, this is a negative. Remember, we're going descending order. 3, 2, 1, then something without a p. Subtract. 4. 7 versus 11 players. Team 11 wins, so that's team negative. So this would be your final answer. To the third, to the second, to the first, remember there's an understood one here, constant terms written last. Now some people are going to be lucky enough to get an easier problem like this, but because Alex is random, some people are going to get ones that have 2 ladders. So I'm going to do another sample question just for those unlucky people who get the harder problem. So notice W's and Z's in the same term. The majority of us will get the first type questions, but there's 1 or 2 of you who might get the challenging one. Because it's so long, I'm just going to write it stepping down. Oops. But I'm hoping I can squeeze this guy in. It kind of works. So this guy is a beast, but it's the same rules. So this first step is we need to get rid of these parentheses. How? Binomial, binomial, trinomial. That means the only way we can get rid of it is slip in an imaginary coefficient of 1 and distribute. So when I do this, notice nothing changes. It's going to be just 12w squared z minus 5wz plus 8wz squared. Now when I distribute a negative 1 here, this becomes negative 1w squared z. See how it was positive? Now it becomes negative. Negative 1 times negative 2 becomes negative 2wz. And now when I distribute this negative 1, because remember I'm distributing the number and its sign. Always distribute that sign. You get negative 4wz, and then positive, because remember negative times negative is positive, 6wz squared. Okay, lots of letters. So let's pair them off. How do we do that? Start alphabetical. So we know we have w's and z's. So let's start with w's. Look for your highest exponent. So we have a w squared here and a w squared here. Notice that these match because the z is to the first power. If this was w squared, but this was w squared z squared, they're separate items. You probably would start with this one and then write this one next. Because once you saw there was a tie for w's, then you would do with the z's, highest exponent would have won. Luckily, we don't have to deal with that. It's just this and this. So this is a positive, this is a negative. So we subtract. Who wins the tug of war? Team positive. And w squared z stays the same variable. W squared z, same variable part. So these two are done. Now, after w squared, we'll do single w's. But notice, single w, single w, single w, single w, single w. There's a tie. And they're not all the same. Ones are z's, some are z squares. So let's start with then z squared, since the w's are all tied. This has a w, but with a z squared. And this has a w with a z squared. So let's combine those two guys. So this is a positive, and this is a positive. So what do we do with two positives? Add. You get 14 wz squared stays the same label, wz squared. Remember, this and this are not like. They have the same variable, but here the squares was the w, here the squares was the z. That little bit makes it a whole different term. Okay? Has to match exactly. This doesn't match exactly, that's why they're two separate terms. Now we can do the plain w's with the plain z's. wz, wz, wz. So we can combine them. This is a negative, this is a negative, this is a negative. So I do two at a time, -5 and -2. Both the same negatives, so we add. We get 7 WZs, negative, negative. Remember, team 5 wins, so it's negative. And then when I bring this down, negative, negative, we add those two. So we're going to get a -11. WZ, WZ, remember, keeps the same WZ. So that's your answer. This one, like I said, is a beast because you got to make sure that w squared z is different from wz squared. It's going to try to trick you up. So if you get one of these problems, take your time. Hopefully, most of you will get the easier one.